students, so here we are with the question third of the exercise 3.7 for the chapter pair of linear equations in two variables. So the question third is, a train covered certain distance at a uniform speed. If the train would have been 10 km per hour faster, it would have taken 2 hours less than the scheduled time. And if the train was slower by 10 km per hour, it would have taken 3 hours more than the scheduled time. Find the distance covered by the train. So in order to solve this question, what I'll be letting is the distance covered by the train be x kilometer. Okay. I have supposed that x kilometer denotes the distance covered by the train. And also let original speed of train be y kilometer per hour. Okay. So as we know the relation between distance, time and speed, what it says, distance is equals to speed into time, which we have read in the earlier classes. And we have supposed that the original speed of the train to be y kilometer per hour and the distance covered by the train to be x kilometer per hour. So means in order to find the time from the two variables, that is time, what we need to do is to divide the distance by speed. Means x by y will denote the scheduled time. So writing the scheduled time is x by y. And if I read this statement, what it says, if the train would have been 10 km per hour faster, means now we have increased the speed of the train, which was earlier by how much? 10 km per hour. Means now the speed of the train will be y plus 10. So y plus 10. And the distance to be covered is same. What it's been given also, it would have taken 2 hours less than the scheduled time. And we know the scheduled time is x by y. And now the time taken by the train is x by y plus 10. And as we increase the speed by 10 km per hour of this train, it would have taken 2 hours less than the scheduled time. So means scheduled times minus now, that is present time taken by the train when its speed have been increased by 10 will be 2. Which is also clear from the logic. What we have been knowing by the logic is, if we increase the denominator, then the fraction will decrease. Or in other words, if we decrease the denominator, then fraction will increase. Means these have the reciprocal relationship. And if we are increasing the denominator, then the fraction will be less than the previous one, means scheduled time. So x minus y will be greater than x by y plus 10. And now read the second statement. What it says, and if the train was lower than 10 km per hour, means now we have decreased the speed of train. As the original speed was y, now it has been decreased by 10, so the speed will be y minus 10. And from here we have seen that it's been reversed, right? It might create the confusion. So read it this way, that is first sign, second sign and second sign, right? So, and if the train was lower by 10 km per hour, means now y minus 10 is the speed of the train and it would have taken 3 hours more than the scheduled time. So, means from here, the statement which can be formed is x by y minus 10 minus x minus y, which is the scheduled time, is equals to 3. These are the two linear equations which we have obtained for this problem. Now, in order to find the value for the variables x and y, let us divide the first statement with the second one. So, divide first by second. So dividing it, x will be the common, will be taken out. In the bracket it will be 1 by y minus 1 by y plus 10, and in the denominator it will be x into 1 by y minus 10 minus 1 by y, which will be equal to 2 by 3. Right? Now from here, x and x will be cancelling out. So we'll be getting 1 by y minus 1 by y plus 10 divided by 1 by y minus 10 minus 1 by y is equals to 2 by 3. Now, solving it, what we will be obtaining is, taking the LCM of the denominator, it will be y plus 10, and in the numerator it will be y plus 10 minus y. And again taking the LCM of the denominator, it will be y into y minus 10, and in the denominator's numerator it will be y minus 10, which is equals to 2 by 3. Right? So now cancelling the common terms, that is y, and here this y and this y. So I'll be getting y plus 10, y minus 10 is equals to 2 by 3. Now cross multiplying, it will be 3y minus 30 is equals to 2y plus 20, or in other words, y is equals to 50. Okay, means the original speed of the train is 50 kilometers per hour. Now, in order to get the value for the variable x, I'll be substituting this value of the y in any of the two linear equations. There is either first or second, the choices being yours. Let me substitute this in first linear equation. So here it will be, from the linear equation, x minus x by y plus 10 is equals to 2. By substituting the value of the y in this equation, it will be x by 50 minus x by 60 is equals to 2, or x by 10, taking common outside, 6 minus 5 divided by 30 is equals to 5, is equals to 2. So from here, the value of the x comes out to be x by 10, 1 by 30 is equals to 2, x by 300 is equals to 2, or I can write it as x is equals to 2 into 300 will be 600 kilometer. Means the speed of the train, or I can say the original speed of the train was 50 kilometer per hour, and the distance being covered by the train is 600 kilometer, which was being asked in the question. So this was all about question 3rd of exercise 3.7. I hope this question is clear to all of you.